Hey guys, today we're going to be learning about nucleophiles and what makes a good nucleophile. Before we go into that though, it's important to understand the basics behind how nucleophiles function and what types of reactions they act in. So let's say we want to replace one substituent on a molecule with another. So here we're replacing bromine with alcohol. This type of reaction happens through something called nucleophilic substitution. Nucleophilic substitution involves three components: a nucleophile, an electrophile, and a leaving group. Our nucleophile forms a bond with our electrophile, which ends up displacing our leaving group. So we can see that in our reaction here, our alcohol is acting as a nucleophile, and it's replacing or substituting our leaving group here, which is bromine, hence the name nucleophilic substitution. So let's look more into that. Since our nucleophile uses electrons to form a bond with our electrophile, nucleophiles are typically very rich in electrons, meaning good nucleophiles have negative charges. Since a negative charge represents an excess of electrons that could be used to form a bond with another atom. On the other hand, electrophiles, which are carbons that leaving groups are on, have partial positive charges. This is because if we look at the dipole of the bond between our carbon and our leaving group here, which the leaving groups are typically halogens like chlorine, bromine, or iodine, the leaving group is more electronegative, giving it a partial negative charge, which leaves our electrophilic carbon with a partial positive charge. Since opposites attract, the negatively charged nucleophile will be attracted to the partial positive electrophile, which will make it be naturally drawn to form a bond with our electrophile. When the nucleophile forms a bond with carbon, carbons can only have 4 bonds, so this displaces our leaving group. So now that we know the basics behind what nucleophiles do, let's look into what makes a nucleophile a good nucleophile. So probably the most important factor in relation to what makes a good nucleophile is that a nucleophile needs to have a negative charge, especially a concentrated negative charge. The reason negative charges are important is because the more negatively charged an atom is, the more willing it will be to give up a lone pair of electrons, give up excess negative charge to form a bond with an electrophile. So let's look at these 3 examples to the left right here. So this example right here does not have any lone pairs because all these carbons are just bonded out with hydrogens. There are no lone pairs on them. So this cannot act as a nucleophile. On the other hand, this example right here, this oxygen does have 2 lone pairs, so it can act as a nucleophile, but it's going to be a weak nucleophile because it doesn't have a negative charge. On the other hand, this example right here is going to be a strong nucleophile because not only do we have lone pairs, but we also have this negative charge here, which represents electrons that are willing to go out and form bonds with electrophiles. The reason that a concentrated negative charge is important, meaning the negative charge is not delocalized by being caught up in resonance, is because if the lone pair of electrons is moving around in the molecule, they're going to be too busy to go out and form a bond with another atom. Remember, resonance makes a molecule more stable, and so if the nucleophile is resonating, it's not going to want to react as much. So if we look at this example to the right here, even though this oxygen has a negative charge, since the negative charge is caught up in resonance, it's going to be a weaker nucleophile because that negative charge is not going to be as willing to go out and react. So the next factor we want to look at is the atom that has the lone pair and therefore is acting as the nucleophile. So firstly, less electronegative atoms are better nucleophiles than more electronegative atoms. So for example, if we're comparing oxygen versus nitrogen with negative charges, Since nitrogen is less electronegative than oxygen, it's going to be a better nucleophile. This is because more electronegative atoms are more electron greedy, meaning they'd rather hold on to the electrons that they have than donate them in the form of a covalent bond to an electrophile. So because of that, nitrogen is going to be a better nucleophile. The other factor with atoms is that larger atoms are better nucleophiles than smaller atoms. So for example, if we're comparing oxygen with a negative charge to sulfur, sulfur is a row below oxygen on the periodic table, meaning it's larger. That means that the electrons in sulfur are further away from the nucleus, so they're less tightly bound to the atom, and they're more free to go out and form bonds with other atoms. So because of that, sulfur is going to be a better nucleophile. And just as a rule of thumb, if you look on the periodic table, atoms going down and to the left on the periodic table are more nucleophilic. So the next factor we're going to look at is the size of the molecule. Less bulky molecules, so smaller molecules, are going to be better nucleophiles. So if we look at these two examples here, this molecule is bulkier than this one, meaning there's a lot more crowding here. There's a lot more carbons that's causing steric hindrance. So since this molecule has a very sterically hindered structure, it's going to be harder for it to attack our electrophile. So because of that, the less bulky molecule is always going to be our better nucleophile. So the last factor we're going to look at doesn't necessarily have to do with the nucleophile itself, but it has to do with whatever substance the nucleophile is dissolved in solution with. So whatever solvent is present in solution. Polar aprotic solvents allow for nucleophiles to act as strong nucleophiles. So let's look at an example here and see what that means. So say we have a reaction where our nucleophile is present in solution with acetone compared to it being present in solution with methanol. So methanol is an example of a polar protic solvent, meaning there's polarity in the solvent molecule, and the solvent also has hydrogens that are covalently bound to oxygen, nitrogen, or fluorine. Methanol here has a hydrogen that's bound to oxygen, so it's polar protic. On the other hand, polar aprotic solvents like acetone are polar, but they do not have a hydrogen bound to oxygen, nitrogen, or fluorine. So acetone here has polarity, but no hydrogens are bound to this oxygen, so it's polar aprotic. So polar protic solvents make our nucleophile weaker because they can actually stabilize our nucleophile. We need to keep in mind the dipole of the bond between oxygen and hydrogen. Oxygen has a partial negative charge and hydrogen has a partial positive charge. The partially positive hydrogen of our solvent is attracted to the negatively charged nucleophile. This attraction is called hydrogen bonding. Hydrogen bonding stabilizes the nucleophile, making it less willing to react. So since acetone is polar aprotic, it does not have this problem. So this is why polar aprotic solvents allow our nucleophile to be a strong nucleophile. So say we were given a question in which we had to rank these molecules by their nucleophilicity, with number 1 being the strongest nucleophile. When we are approaching these problems, we want to keep in mind that the first thing we have to look at is whether or not these nucleophiles are charged. Charged nucleophiles are always going to be stronger than uncharged ones. So looking at all these molecules, this one on the way right here is the only one that's not charged, so I'm going to rank it number 4. Next, I want to look at the atom that has the charge and acts as the nucleophile. Atoms going to the left and down on the periodic table are better nucleophiles because they're less electronegative and they're larger. So looking at these molecules, carbons are better nucleophiles than oxygens because they're less electronegative, so they're more willing to give up excess electrons in the form of a bond. So because of that, this is going to be our number 1. The last thing we want to look at is other factors like resonance and bulkiness, since these decrease nucleophilicity. So looking here, this negative charge on this molecule can resonate, making it less available to act as a nucleophile. So this will be our number 3, and this other molecule will be number 2. So I hope this video helped you guys learn more about nucleophiles. Thank you for watching, and best of luck on the rest of your semester.